and welcome to our webinar with the interesting topic VLC 350 GT, the perfect solution for gear production in the commercial vehicle industry. My name is Melanie Bellmer and I'm very pleased that so many of you are taking part today. We have two experts for this topic in the studio today. Firstly, I would like to welcome Ms. Marina Manger very warmly. She joined the eMAG Group 12 years ago and works at the technical sales department. Secondly, we have Mr. Patrick Schlosser with us. He joined the eMAG Group 6 years ago and also works at the technical sales department. And Marina and Patrick will guide us through the webinar today. Now I directly give the floor to Marina and wish you a lot of fun with our webinar.
Yeah, thank you, Melanie. We have a big audience today and we are glad to introduce our new machine, and we will start directly with our presentation.
Melanie has already explained what VLC 350 GT means. In 1992, the production technology is revolutionized. eMAG brought the VSC, the world's first vertical turning center with pickup spindle, onto the market. The machine base made of mineralite, the integrated automation system with pickup spindles, and the free downward chip flow all combined to make the VSC an extremely successful product. The year 1998 saw the launch of the world's first combined turning grinding center based on the VSC machine. The development of super hard cutting tools for turning makes it possible to combine the technology hard turning and grinding. This combined machining is now well established in the market. Due to increased demands for ergonomic operation, setup-friendly arrangement and flexibility, eMAG develops the VLC 250DS in 2009. The consequent further development leads in 2015 to the VLC 200 GT. The main area of application for the VLC 250 GT are gear wheels for passenger cars. Meanwhile, over 100 VLC 200 GT machines with many different configurations were delivered. This success based on cost-optimized design. Less workpiece cost are the result for the end user. Due to this success, the VLC 350 GT was developed. To complement this system, the VLC 350 GT is now available for gear wheels in commercial vehicles. Now I want to explain the VLC 350 GT. Basically, the VLC 200 GT and the VLC 350 GT have the same structure. Different machining stations could be integrated. Very often the configuration looks like that. On the left-hand side we have the automation area. For the automation we use a conveyor belt or a shuttle. The main spindle picks up the part from the pickup station and bring the machine parts back to that area. The main spindle is located on a cross slide with axes X and Z. The turret has 12 places for tools. Different interfaces are possible, for example VDI or Capto. Optional driven tools could be used. We can choose internal grinding spindles with different speed ranges. The interface for the tool is HSK. The internal grinding spindles are oil-air lubricated. The external grinding spindle could be mounted straight or under an angle. This grinding spindle has an integrated balancing system and is lifetime grease lubricated. The diameter of the grinding wheel is 400 mm. The grinding wheels are dressed with a rotating diamond form roll, driven by a dressing spindle. The dressing spindle is mounted on the left-hand side of the main spindle and moves together with the main spindle. The measuring probe is placed outside of the working area to be protected against chips. The technology-assisted sensing completes the machine. The hardware base for the technology-assisted sensing is the process control tool, or short PCT. This is used on all eMAG combined turning grinding machines. With that we realize At first, the cutting sensor for the grinding wheel, and second, the dressing sensor for dressing of super hard grinding wheels. What will the machining of a workpiece look like according to this machine configuration?
With the previously shown application, turret, internal grinding spindle and external grinding spindle, you can machine the gear perfectly in one setup. In the most cases, the end faces are hard turned, shown on the picture 1 and 2. Depend on the allowance, we will pre-turn the bore and the corn. Therefore, a constant allowance can be realized. After that, we will grind the bore and the corn. We pre-turn and grind. This makes it possible to reduce the cycle time in cases of big or unstable allowance. This is the big advantage of the combined process. If you only use a grinding machine, the geometry of the workpieces often does not allow to grind the faces in one setup. This means that for small bores and large faces, it is necessary to machine the part in two setups. The high reachable parameters of quality and precision at the grinding process can be combined with the advantages of the hard turning process. All these things give us an optimal process. Now we will show you a short movie of the VLC200 GT machine. Here you see the VLC200 GT machine, the working area, here we see the E-shuttle with the two positions, raw part and finished part position, drives into the machine. Now the main spindle brings the finished workpiece, and now the main spindle pick up the raw part. We turn the faces, pre-turn the ID, turn the back face, then rewind the ID, grind the corn, and at least we will measure the workpiece. The previous example shows the configuration of turret, internal grinding spindle, external grinding spindle. But also other configurations are possible. The working area with the 3 machining stations can be adjusted completely to the customer specification requirements. Possible configurations are 2 internal grinding spindle with a turret, 2 internal grinding spindle, external grinding spindle. Here is no turret in the machine, a turret and an external grinding spindle. Here at picture 4 you see a horning unit and an internal grinding spindle with a turret, and at least we see a turret with an ID grinding spindle. As well, other configurations are possible. On the next page we will show some of the automation possibilities. We have a lot of different possibilities to automate our machine. We have the Emax standard automation with conveyor belt or shuttle. The worker can load and unload the raw and finished workpieces on the conveyor belt. The conveyor belt can be used as a buffer. The shuttle has two places for raw and for finished workpiece. The shuttle could be loaded with a gantry loader or a robot. On the right hand side you can see an automation with a basket stock storage from EMAG. The picture below shows an integration of the machine in a product line. The pages above are basically valid for both machine types VLC 200 GT and VLC 350 GT. The only difference is the size of the workpieces. Of course, the main components such as main spindle, guides and drives are assigned for the relevant workpieces. The picture shows the technical data of both machine types. The main features here is the different chuck diameter of 210 mm on the VLC 200 GT and 400 mm on the VLC 350 GT. The bearing of the main spindle with a diameter of 110 mm on the VLC 200 GT and 160 mm on the VLC 350 GT is extremely strong. With the linear motor on the VLC 350 GT in the x-axis we realize very short chip-to-chip times. But what is new on the VLC 350 GT? We will show you on the next pictures. The first innovation is the optional B-axis. On this B-axis the internal grinding spindle can be mounted. Therefore it is possible to grind in a variable angle. For which application can you use the internal grinding spindle on the B-axis? This you will see on the next pages. Do you imagine you have a large range of parts with a low batch size? Some workpieces have holes and some have an inner corner. Normally you have to change the grinding wheels for these operations. We have the following solution. The internal grinding spindle will be mounted on the B-axis. For grinding the corns we will swing the B-axis. Here we can grind with a cylindrical grinding wheel. In this case you are very flexible and can cover a high spectrum of gears. In the next example, you have workpieces with different bore diameters. Therefore, two internal grinding spindles are necessary. In some of the workpieces, you have also to grind a face. The solution? The face will be grinded by a swivel internal grinding tool. And here the B-axis is your solution. The second innovation is the optional Y-axis for the turret. It can be used for milling of nuts, spiral grooves or key faces with a live tool. And finally, we will show you a few application examples which shows the flexibility of the machine.
Example 1. Grinding of a CVT pulley. In that case, we use a machine with 3 grinding spindles. In the first station is the external grinding spindle, which is mounted under an angle. The second station is for grinding the bore, red marked. The third station is for grinding the internal nut. For correction of actual set-off, the ball nut unit is mounted on the y-axis. Example 2. Grinding of a control plate for an axial piston pump. The control plate will be machined in 2 setups in the same machine. In the first setup, we grind the bore and the face. Then we turn around the part and the ball will be ground. Different angles are adjusted by using the B-axis. Example 3. Non-round grinding of an internal shape of pump ring. The pump ring will be centered at the external diameter and clamped with axial clamping fingers. The machining is done by interpolation of axes C and X. If the stock allowance is big, we could machine the shape into operation, means by using pre- and finish grinding. Due to the linear drive, we don't have backlash. At the end, a short summary. The combination of different technologies allows the complete hard machining of the workpiece in one setup, makes the complete machining process perfect, avoids technological border areas, allows an efficient and safe process chain with low workpiece costs. The big machining area and the long X travel makes it possible to have a lot of different machining configurations and enables a big number of technology concepts. The X-axis with linear drive ensures high speed with minimum idle time and has no backlash and is therefore a good basis for non-round machining.
Yeah, thank you, Marina and Patrick, and for you, welcome back. As already mentioned, we will now come to your questions.
How does the dressing of the grinding wheel work?
For that we use a diamond form roll, and that diamond roll is mounted on a dressing spindle. If we grind with CBN or other super hard grinding wheels, it's necessary to have a sensor in the dressing spindle to avoid to dress too much material from the expensive CBN grinding wheel. And for that we use acoustic emission in the dressing spindle, and the information from the acoustic sensor will be analyzed in the PCT module. I have explained that further in my presentation, and that information is then visible on the screen. The dressing spindle is on the left-hand side of the main spindle and moves together with the main spindle in the two axis direction, in Z and in X. And with that we move to the grinding wheel and dress 1 times, 3 times, 4 times the grinding wheel. So we get in contact with the diamond form roll and the grinding wheel and correct the shape of the grinding wheel.
Then we will just answer the questions from the live chat before. So the first question is, how does the robot integration look like? Can the machine be loaded by robots?
I will answer this question. Yeah, the machine can be loaded with the robot. We have an e-shuttle in the machine, and the e-shuttle with a raw and a finished workpiece drives outside of the machine. And in this area, you can load and unload with a robot or also with a gantry. And when you have some own robot cell, it's also possible to integrate in our machine. Here we have an interface, a robot interface, which shares the informations between the machine and your robot cell.
A few more questions from the live chat. The next one is, what is the angle of the B-axis?
Yeah, the angle of the B-axis is plus minus 15 degrees, and it's 3 movable. It's you can move it, you can program with the INC program in the machine.
Can the machine also be used for milling?
You're the former milling specialist.
Yeah, of course you can mill with the machine. We have the option with the mill with the turret with a live tool, milling vertical or horizontal. Here we can also use our Y axis with the turret to mill maybe nuts. And we have also the opportunity, when you need more torque with milling, to integrate a milling spindle.
Can shafts also be machined?
Of course, the shaft can be machined. Normally, you produce the shafts with two pins for turning and for grinding. Here we can combine the turning in the grinding process in our machine, but we have to share the shaft in two sides. OP10 we can make 1/2 of the shafts. Pre-turning, ID, OD, we can grind the OD and we can grind the ID. Maybe we can also make some nuts in the shafts, and then we have to move in the shafts in OP20 and make it the other side, also pre-turning, finish turning or grinding. And it's also possible to ream the whole ID and maybe also horning is possible.
Only in addition, we have to keep in mind that we only have 350 millimeters ZX strokes, and so we have to check if the shaft fits in the machine.
Okay, yes, then we would say thank you again for your participation, also in the name of our 2 experts here in the studio. And yes, take care and maybe until next time.